Hello and welcome to my physics classes. My dear students, I hope you all are fine and doing well. Hard labor does pay, but smart study is the key of success. Now let us begin with the solution of question number 26 of the chapter Physics and Mathematics. The question is written here. Find the area bounded by the curve y is equal to e to the power minus x, the x-axis and the y-axis. Okay, the x-axis and the y-axis. So let us make the graph. The curve y is equal to e to the power minus x. First of all, since x-axis and y-axis is given, then we have to find the point on x-axis and y-axis where the graph meets, so that we can find the enclosed area. So when x equal to 0, let us see where this graph meets y-axis. X is equal to 0, then y is equal to how much? Is equal to 0, 1. That is 0, 1 is the coordinate. Suppose 0, 1 is here. The graph will meet here. Again at x is equal to infinity, y will be equal to e to the power infinity. 1 by e to the power infinity is equal to 1 by infinity equal to 0. That means when x approaches infinity, not equal to infinity, but approaches infinity, but for the sake of convenience, we can write here x is equal to infinity. X in approaches at infinity, y equal to 0, means the graph is just very closer, very closer. You can write approximately for the sake of convenience to calculate the area. This is the area which you have to calculate. Let us take dx width of this small strip and let the strip move from this point to this point, from x is equal to 0 to infinity. So area A is equal to integration y dx from 0 to infinity. This is the area which we have to calculate. I think you have got it, the point. Now this is the question we have to do it, and that is the graph. So let us put the value of y and then solve it. A equal to 0 to infinity e to the power minus x dx. Integration of e to the power minus x is equal to e to the power minus x by minus 1, and this lower limit will be here and upper limit will be here. This is the as per rule of integration, and the indefinite integration, the lower limit will be 0 and upper limit will be infinity. Here you can write minus e to the power minus x 0 to infinity minus e to the power minus infinity minus e to the power 0. That is area A, okay, is equal to, what does it mean? 1 by e to the power infinity. 1 by e to the power infinity means 1 by infinity, that means 0, and its value will be equal to 1. So this is minus 0 minus 1, that is equal to 1. Answer is 1 square unit. This is the required area. This is the answer. Okay. That's very easy question. Now let us move towards question number 27. Question number 27. I will write the question first. Okay. Question 27 says, this is the book H.C.VERMA book, that is Concept of Physics. A rod of length L, a rod of length L, a rod of length L is placed along the x-axis, along the x-axis, along the x-axis between x is equal to 0 and x is equal to 0, x is equal to L, between x is equal to 0 to x is equal to L. The linear density, that is mass per unit length, the linear density rho, the linear density, that is mass per unit length, that is mass per unit length, rho of the rod, rho of the rod varies with the distance x, varies with the distance x. Okay, varies with the distance x from the origin as, from the origin as rho is equal to a plus bx. Then find the SI units of A and B. Find the SI unit. This is the aeroplane sound which is disturbing time to time. Find the SI unit. Find the SI units. Find the SI units of A and B. Of A and B. The question B, part B of this question. Find the mass of the rod in terms of AB and L. Find the mass of the rod in terms of A, B and L. Okay. So this is the question. First of all, understand the meaning of the question. A rod of length L is placed along the x-axis between x is equal to 0 to x is equal to L. This is the rod between x is equal to 0 to x is equal to L. That is, this is the, suppose this is x-axis, this is y-axis. From x is equal to 0 to x is equal to L. The linear density rho of the rod varies with the distance x. As distance increases, the linear density rho varies as per relation given rho is equal to a plus bx. Okay, rho is equal to a plus bx. This is what? This is mass per unit length. This is mass per unit length, that is density. Find the SI unit of A and B. Okay, I think you have got the meaning of the question. Pause the video and read the question. Okay, I am omitting the question part. Here, find the SI unit of A and B. SI unit of A and B. SI unit of A and B. Since rho is equal to A plus Bx, here A and B, you can find the dimensional formula of A and B, and then you can write the unit of A and B. This is density, mass per unit length, and by theory of homogeneity, A will also be density, Bx will also be density. So A is equal to mass by length. Dimensional formula will be ml minus 1, that is unit kg per meter. This means what? Kg per meter. This is the unit. This implies unit will be kg per meter for A. And for B, Bx is also density, mass by length. Here you can say B is equal to m by L, and x is also L square. You can write here mass, the unit will be kg per meter square. This is the unit of B, kg per meter square. I think you have got the meaning. Okay, let us check the camera. Okay. Now, the first part, find the SI unit of A and B, is clear. Now, for the second part of the question, that is find the mass of the rod in terms of A, B and L. In terms of A, B, L, A, B and L. For mass, you can take a strip here, ds length, and its mass will be dm. That is dm by mass per unit length. This is also equal to m by L. Here we can write dm is equal to m by L dx. So we can integrate this function, and you can vary the value x from 0 to L. So now the solution is given by integrating this dm m by L dx, integrating it, the required mass m will be equal to m by L is the density, that is rho, that is A plus Bx dx, and it varies from 0 to L. Now we can integrate A dx from 0 to L plus Bx dx from 0 to L. We can integrate both part. Okay. So the value of integration, its value comes out to be mass m is equal to A dx 0 to L plus Bx dx from 0 to L, integration A dx, integration is x from 0 to L plus Bx square by 2 from 0 to L, that is A L minus 0 plus B by 2 x square 0 to L. You know very well about integration. This is very simple integration. Integration of dx is x, and integration of x dx, since x to the power 1, Therefore, you know the formula for integration. X to the power n dx. What is the formula for integration? It is x n plus 1 by n plus 1. On this basis, its value can be written as x1 plus 1 by 1 plus 1, that is x square by 2. So integration of x dx will be x square by 2. You can check here. And 2 is constant, b by 2, x square. It varies from 0 to L, lower limit 0, upper limit L. Here we have put the value. This is AL, and you can put value here. X square, that is L square minus 0 square. As per rule of definite integration, the value upper limit at place of x minus lower limit at place of x. So its answer will be AL plus B by 2 L square. This is the mass of the rod. You can check the answer. It was question number 27. Its answer AL plus half BL square. Half BL square. Okay, it's correct. Okay. Now question number 28. I think you have got it. Please write it. Okay. Everything is clear? Okay. Now let us move to question 28. 28. Question 28. Let us move to question 28. 28 question says that the momentum P of a particle, 28. The momentum P of a particle, the momentum P of a particle, the momentum P of a particle changes with time. Changes with time. Okay, the momentum P of a particle changes with time t. According to the relation, dP by dt equal to 10 Newton plus 2 Newton per second t. If the momentum is 0 at t is equal to 0, if the momentum is 0 at t is equal to 0, if the momentum is 0 at t is equal to 0, what will be the momentum? What will the momentum be? What will the momentum be? What will the momentum be at t is equal to 10 seconds? At t is equal to 10 seconds. Okay. The momentum P of a particle changes with time t according to the relation dP by dt, 10 Newton plus this 2 Newton. 10 plus, basically it is 10 plus 2t. If the momentum is 0 at t is equal to 0, what will the momentum be at t is equal to 10 seconds? Now, solution means the momentum varies from 0 to 10 seconds. Basically, it is asking momentum from 0 to 10 is equal to what? Okay, you can write here. It is given that dP by dt is equal to 10 plus 2t. It is given. You can write here dP is equal to 10 plus 2t dt. 10 plus 2t dt, 2t dt. First of all, integrate it so that we can find the momentum in terms of t, in function of t. So integrating p is equal to, its integration will be p, 10 plus 2t dt. Now from 0 to 10, the change takes place from 0 to 10. At t is equal to 10 seconds, we can find the value after integration. So let us integrate it. Okay. This is the question. Read it carefully, then approach like this. Okay, the p is equal to 10 plus 2t integration 0 to 10 dt, split in two parts, 10 dt from 0 to 10 plus 2t dt, 2 is here, from 0 to 10, and here 10 dt. You can write this 10 here and dt here, like that. Okay, so 10 dt, integration of dt is t, and it varies from 0 to 10 plus 2 in t dt, 2 dt, that is t square by 2 from 0 to 10. This is the value here. Okay, now integrating it, after integration its value comes out to be 10 minus 0 plus 2 by 2 t square, that is 10 square minus 0. Okay, upper limit, that is 100 plus 2 to cancel 100, it is 200. This is momentum, linear momentum. Okay, p is equal to, unit is kg meter per second, kg meter per second. This is the answer. Okay, this is kg meter per second. I think you have got it. Okay, now let us move towards question 29. 29. Question number 29. It was 28. 29. Question number 29. In 29, the changes in a function y, the changes in a function y and the function y and the independent variable x and the independent variable x are related as dy by dx is equal to x square. Find y as a function of x. Find y as a function of x. This is nothing but the integration only. Only we have to solve the integration question. Okay, it is 100% integration. That is dy given dy by dx is equal to x square. You can write here dy is equal to x square dx. And what is the formula for integration? X to the power n dx. It is x n plus 1 by n plus 1. Here it is x square dx. On the basis of this formula, you can write x 2 plus 1 by 2 plus 1, that is x cube by 3. So its value will be, integrating it, y is equal to x 3 by 3, and it is a function c here, because after integration we add any constant. So y is equal to x by 3 plus c. This is the answer here. Y is equal to x cube by 3 plus c. This is the answer here. This is pure 100% the question of integration. Okay. Now question number 30. Question number, I think you have written it and understood it. Okay. Let us move for the next question. The next question is question 30th. Question 30th. What this question says: write the number of significant digits. Write the number of significant digits in A. 1001, B 100.1, 100.1, C 100.10, and D 0.001, 0.001. Okay. Question number 30th. Write the number of significant digits. 1 and 1 both are significant, and 2 zeros are trapped between two significant figures. So both 0 will also be significant as per rule of significant figure. In between two significant figures, 0 is also significant. That is 1, 2, 3, 4. So its first answer, its significant figure will be 4. Now B. It is also similar. Two significant figure, whatever be the decimal. Again 4, 1, 2, 3, 4. The same rule. Here I have written similar 1001, 100.1, and C 100.10. C 100.10. Okay. Here also 4. Here 100.10. After decimal, the 0 is counted in significant digit, significant figure. 0 is counted as significant figure after decimal. So this 0 will also be significant. 1, 2, 3, 4, 5. So significant figure is 5. And now come here. The beginning 0. This 0 has no significance, because as per rule of significant figure, the initial 0 will have no significant figure. That will not be significant. So after decimal, this 1, 0, 1, 0, this is 4. So this is the answer for the significant figure. 444, 4454, 4454. I think you got it. Okay. Here it is beginning 0, 0, 0, 0, 0, 0, 0. So it is not counted in as a significant figure. So now let us move to question 31. Question 31. 31 says, question 31. A meter scale is graduated at every millimeter. A meter scale is graduated a meter scale is graduated at every millimeter millimeter. METR at every millimeter. How many significant digits? How many significant digit? How many significant digit? Okay, how many significant digits? Will be there in a length measurement okay with this scale so this is the question here. Question number, it was 31. Okay, solution. A meter scale is graduated at every millimeter. There is a meter scale graduated at every millimeter. 1 meter is equal to 1000 millimeter. You know it very well. It is graduated means 1000 millimeter is mentioned. Each millimeter are mentioned in 1 meter. There are 4 digits, 1000, 4 digits. But here question is that significant digits. How many significant digits could be here? Okay. Actually, in this number 100, there is no as per rule of significant figure. 000 are not significant after 1. If it were after decimal, then it would be significant. But there is no decimal term. Therefore, after 1, after n digit, all zeros are not having any significance. But here, since how many, there are 4 places, 1, 2, 3, after 1, there are 4 places where the significant digit could be placed. Here from 1, here it is 1. It can be the second, third and fourth. Means there are 4 places where significant figure could take place. 1, 2, 3 and 4. There are 4 significant figures which could be written as 1, 2, 3 or 4. 1 significant digit or 2 significant digit or 3 or 4, because there are 4 places where significant figure could be placed. So significant digit could be placed. So this is the, as per rule, we can say that 1, 2, 3 and 4. There are 4 digits which are possible to put here. So this is the answer here. From 1 to 4, 1 or 2 or 3 or 4 significant digit. It 4 places can occupy 4 significant digit. Now the question number 32. Question number 32. Question number 32. Question number 32. Round the following numbers. Round the following numbers to 2 significant digits. To 2 significant digits. To 2 significant digits. First is 3472, 3472, B 84.16, C 2.55, and D 28.5. Okay. Solution. Round the following numbers to 2 significant digits. Actually, here 3472, 2 significant digit. 3472. We have to round only up to 2 significant digit. So after 2 significant digit, it is 7, more than 5. We can write here 3, 5 and then 0, because this 0 and 0 is not, both 0 are not significant here, and question says you have to convert into 2 significant only, so it is closer to this. Therefore 35, 0, 0, this is the answer. Now B 84.16, 84.16, 2 significant digit 84. It is asking for 2 significant, then this is 84 only, because it is 0.16, less than 5, and we want only 2 significant digit. C 2.55. Think over this. What would be the value of 2.55? 2.55. It is more than 2.55. It is repeated number, and we have to write 2 significant only. Here you can write 6, because 5 is repeated, and we have to write up to 2 significant digit only. So 2.6. Now the third one is how much? 28.5. There is no repetition of 5 and up to 2 digit only, therefore it is 28 only. It is okay. This is the answer here. Okay, as per rule I have written all the answer. This is 28. So this 32, question number 32 is completed now. Now question number 33. Question number 33. 33. Question number 33. It says the length and the radius of a cylinder. The length and the radius of the length and the radius of a cylinder measured with the length and radius of the cylinder measured with a slide calipers calipers are found to be 4.44 centimeter and 1.75 centimeter respectively. Calculate the volume of the cylinder. This is the question here. The length and the radius of the cylinder measured with the slide calipers. Solution: the length given that the length L is equal to 4.54 centimeter and radius is 1.75 centimeter respectively. Calculate the volume of the cylinder. Then volume of the cylinder is equal to what? Okay. We want volume of the cylinder. We know very well volume of the cylinder. V is equal to how much? Volume of the cylinder pi r square L. We can write here 22/7 into r square, 1.75 into L, 4.54. This is given in centimeter. Okay. The answer will be in centimeter cube also. We have to calculate it. I think you have written the question. Okay. So let us calculate. Let us calculate the value. 1.75, 1.75, 1.75. Let us check it. Okay. One, two, three, four. 3.0625. Its value comes to be 3.0625. Now into 4.54. 4.54. Multiply it. I think you calculate by your own way. You can calculate. Okay, now you can check it. Now 22 by 7. 3.14 you can write. 22 by 7. 3.14. How much its value? You should calculate also its value. Actually its value finally comes out to be, in answer its value comes out to be, its value comes out to be 43.7 centimeter cube. There is something different calculation. You can calculate as per your, on the basis of your calculation rule, whatever you want to do, calculate by calculator or its answer after calculation will be 43.7. Okay, please recalculate it. Its value you can calculate, that will be 43.7. Actually the main purpose is to where to put the decimal place, the how many you can say the significant figure would be there. So there are three minimum significant figure in all cases given here, because in radius 3 significant figure, in length there are 3 significant figure. So in answer there should be 3 significant figure. So the answer is given in 3 significant figure. The main purpose is that. Okay, you can check it. Calculation is your part. Calculation you can do, because here it will take a long time by calculator or whatever method you have. So now let us move to the next question. That is question number 34. The thickness of a glass plate is measured to be the thickness of a glass plate is measured to be the thickness of a glass plate is measured to be 2.17 mm, 2.17 mm, it is repeated number, and 2.18 mm and 2.18 mm at 3 different places. At 3 different places. Find the average thickness of the plate from this data. Find the average thickness of the plate from this data. Okay, this is question number 34. Thickness of glass plate is measured to be 2.17 mm, 2.17 mm, 2.18 mm. 3 measurements, 3 values of the measurements. Okay, 3 values of this measurement, 3 different values here are same at 3 different places. Find the average thickness of the plate. Okay, solution. Average thickness, that is the general formula for the calculation of average value. That is, the average value is given by the average thickness is equal to add all these 3 values and divide by 3. 2.17 mm, 2.17 plus 2.17 plus 2.18 divided by 3. We have to add these 3 data. What is value? 2.17, 2.17, 2.18. Let us add it. 22, 5, 6. That is 6.52 by 3. You can write here. And so on. But the answer, the smallest significant number in every measurement is 3. So the answer will be in 3 significant from here to here. That is 2.17. 2.17 millimeter mm. This is the answer. I think you got it. Okay? Write it. This is very easy question. Easiest question. Now the last one question of this chapter, physics and measurement. The last question, that is 35th question. 35th question. The last one. Let us write the question. Question number 35. The length of the string, the length of the string of a simple pendulum, of a simple pendulum, of a simple pendulum is measured with a meter scale, to be 90.0 centimeter. Okay, 90.0 centimeter. The radius of the bob, the radius of the bob plus the length of the hook, plus the length of the hook is calculated to be 2.13 centimeter, using measurements with a slide, using measurements with a slide calipers. Okay, calipers. What is the effective length of the pendulum? What is the effective length of the pendulum? The effective length is defined as the distance between the point of suspension and the center of the bob. It is written in the question. I can also write here. It is written in the question that the effective length is defined as the distance between point. I can write here the effective length is defined as the distance between the point of suspension and the center of the bob. Okay. The length of the string of a simple pendulum. Let us understand the meaning of the question. The length of the string of a simple pendulum is measured with a meter scale to be 90.0 centimeter. The radius of the bob plus the length of the hook is calculated to be 2.13 centimeter. The radius of the bob plus the length of the hook is calculated to be 2.13 centimeter using measurements with a slide calipers. What is the effective length of the pendulum? Okay. I think you have got the meaning of the question. Here is the pendulum. Here is the length of the string. It is 90 points. This is the length, 90.0 centimeter. Okay, and the radius of the bob plus the length of the hook. The radius of the bob. This is the radius. This is the length. This is the radius. Means length is given to be 90.0 centimeter and radius is given 2.13 centimeter. Okay. What could be the value? What is the effective length of the pendulum? This is L plus R is the effective length of the pendulum. Effective length L plus R. 90.0 centimeter plus 2.13 centimeter. You can add it 2.13 here. You can write here. I think you have written the question. Now let us erase the question here. This is the length, this is the radius, OAB, B the point. So effective length is equal to L plus R. L is given 90 plus 0 centimeter plus R is given 2.13 centimeter. We can add here 90 plus 0, 2.133129. But the answer, the significant figure, the minimum number of significant figure in any measurement, that is here there are 3 significant figure here and 3 significant figure also here. The minimum number of significant figure is 3, but in addition, since the decimal is given after 2 digit, so here in addition there is no need to think over the significant figure, but we can take only 3 digits, after decimal only 1 digit here. This could be the answer, this centimeter. This is the effective length. Okay. So this is the effective length. I think the chapter Physics and Mathematics, this chapter is completed now. There were 35 questions in all in this chapter, and I have solved it in, I think in 4 videos, I think. Okay, so you can check. In 1 hour class I solve whatever number of questions could be solved, and slowly I want to solve the question so that even below average students could understand the solution. This is for your you can say convenience. And one thing, if you want to see the video in fast form, then you can double its speed, it is in your hand. If you want to understand the question and any concept, then you can pause the video, it is in your hand. So my dear students, the lecture of today is going to over now. One thing I keep saying, please practice and do practice.